Given question is find DFA for language L equal to A power M, B power N such that M greater than or equal to 0, N greater than or equal to 0. And we need to find the transition function for a valid string as well as invalid string. So first let us take this language, and these are the possible strings that comes under this language. So we need to draw DFA for this language. So first, if you take this Q naught, this is the initial state and final state also. So this step or this state, it will accept all possible combinations of A's. So only A's. So here starting state and ending state both are same. So it will accept AA or single A, 3 A's and so on. And if you extend it further, so here you can see step 2. We are adding one more state to step 1 and the input symbol is B. So this will accept strings starting with A, ending with B. So you can have any number of A's but only single B. But in the language we can have any number of B's also. If you see this, there are 2 B's. Okay. So in again we need to extend it further now. So if you place this self loop on Q1, then you will get strings starting with A, ending with any number of B's. This is a self loop, right? And at the beginning, you can have any number of A's. Okay, so Q naught on input symbol A and B were considered, but on Q1, we applied only input symbol B. Then where to apply input symbol A? Say for example, if you take A comma B on Q1, then string will end with A also. But according to the given condition, string should end only with B. Right? So as string ends only with B, we can't place A here. So for that reason, we are taking one state which is a dead state and moving this A here. So all the strings that ends with A, they'll be rejected and only the strings which ends with B will be accepted by the automata. So this is a final DFA for the given question or for the given language. Now we need to validate strings using extended transition function, and this is the notation for that. So first we need to pick one valid string from the language. So here you can see AAB is a valid string. So take that and we need to show why it is a valid string. So we need to prove that. For that, so take this transition function. In place of Q, we are placing Q naught. Here you need to place the input string. So Q naught is the initial state. So you need to check Q naught on input symbol A first. So take only first character from the input symbol. So Q naught on A. So what is Q naught on A here? It is Q naught only. So we got Q naught. Now take next symbol. So take first 2 symbols in the second step. So this can be written as delta of delta star. In place of Q, we'll write Q naught. And here we'll write A. And this place again, it is A. Right? So here this delta dash or delta star of Q naught on A. Again Q naught on A is Q naught only. And write the input symbol as it is. So find out delta of Q naught on A. Q naught on A is Q naught itself. Then take all the 3 characters now. So initially we have considered only 1 character from input, then 2 characters, now all the characters, 3 characters. So here this can be written as delta of delta star of Q naught comma first 2 characters AA and last one separately. So Q naught of A comma A, Q naught comma AA, it is Q naught. So we already got that value. So place Q naught and here it is, write it as B. So delta of Q naught on B check this. Q naught on B is Q1. Check whether that Q1 is a final state or not. Yes. So we can say that the string is a valid string, or that string is accepted by the automata. Now take invalid string which does not belong to the language. So ABA, here the string is ending with A, so that is not a valid one. So I'm taking this again, follow the same process. First take one input symbol, then apply on two, then apply on all the three input symbols. Here we got the value as QD, some dead state. But QD or QS, so you can take anything. So this is not a final state. This one, right? This is a dead state. So we can say that this string is invalid or it is rejected by the automata. Minimize the following DFA, write the steps for minimization. So this is a diagram. First, we need to construct the transition table for this. So first find out Q naught on input symbol A is Q1. Then Q naught on input symbol B goes to Q3. Q1 on input symbol A, it stays in same state Q1. Q1 on input symbol B goes to Q2. So like this, we'll design transition table. And after this, we need to find out zero equivalence, which is represented with pi naught. So here for pi naught, we need to place all non-final states in one set and final state in another set. So all these states from Q0 to Q3, they should be placed in one set and final state Q4 in another set. So that is zero equivalence. After this, find out one equivalence. So here we need to solve Q0 Q1, Q0 Q2, Q0 Q3. So check equivalence for Q0 Q1 first. So input symbols are A and B. So Q0 on A, Q1 on A. Q0 on B, Q1 on B. So we need to take input symbol A and B on both the states. So for Q0 on A, it is Q1. And Q1 on A is Q1. Then Q0 on B is Q3. Q1 on B is Q2. Now you need to check whether both these states are present in the same set or not. Q1, Q1. So both are identical. So they are not present. So no need to check them separately. Both of them should be considered as identical or equivalent. Whereas here Q3 and Q2, check if both are present in same set. Yes, they are present in set 1. So we can say that Q0 and Q1 are equivalent. Now check Q0, Q2 combination. So Q0 on A, again we got Q1, Q2 on A is Q1, Q0 on B is Q3, Q2 on B is Q4. So check Q1, Q1. Yes, identical. Q3, Q4. So if you see this, Q3 is in one set and Q4 is in another set. So we can say that Q0 is not equivalent to Q2. So if any one of them fails the condition, what is the condition? So both the states should be in same set. So if any one of them fails that criteria, then we should consider that as not equivalent case. Then check for Q0 and Q3. So here Q0 on A is Q1, Q3 on A is Q1, Q0 on B is Q3, Q3 on B is Q3. So here both are same Q1, Q1, Q3, Q3. So obviously they'll stay in same set. So we can say that Q0 is equivalent to Q3. Okay, so we completed all these combinations. So now we'll get one equivalence, pi 1 equal to. So here Q0 is equivalent to Q1, whereas Q0 is not equivalent to Q2. So remove that Q2 out from the previous set and keep all Q0, Q1, Q3 in same set, whereas Q2 in another set, Q4 just like before in a separate set. Now find out two equivalents. So here you need to check Q0, Q1, Q0, Q3. This should be verified from pi 1 but not from pi naught in this case in two equivalents. So check Q0 on A. So we got Q1, Q1, Q3, Q2. So no need to check this separately. Here if you see Q3, Q2, Q2 is in separate set and Q3 is in separate set. So both of them are not equivalent. So we'll write Q0 not equivalent to Q1. Then check Q0 and Q3. Q0 and Q3 are present in same set in pi 1. So they are equivalent. So from this, we'll get pi 2 as, so as Q0, Q3 are equivalent, we'll place in one set, Q2 in a separate set, Q1 in separate set, and Q4 in separate set. Then find out three equivalents. So you need to check Q0, Q3 in this case. So we got Q1, Q1, Q3, Q3. So obviously they'll be present in same set. So we can say Q0 equivalent to Q3. So as so if you write this pi 3, you can see that pi 3 is equivalent to pi 2. There is no change. So you can stop the process here. And we got the minimized states as Q0, Q3, Q1, Q2, Q4, where Q4 is the final state and Q0 is the initial state. So you can draw the final automata here. Then next question is construct finite automata for the regular expression 111 whole star plus 111 whole star. So here the input symbol is 1 and we are applying subset method in this case. So if you take 111, so we already know the notations, three notations we saw in the previous video. So here if you take 111, that can be represented like this 1 epsilon 1 epsilon 1. So there's a notation. Whereas 111 whole star should be represented in this way. So you need to mention states in this like Q0. Here it is Q1, Q2, Q3. Inside the circle, we need to mention states as well. Then if you take the second part, this 5 ones. So 5 ones can be represented like this 1 epsilon, 1 epsilon, 1 epsilon, 1 epsilon, and so on. So we need to get all 5 ones. So this is a representation for all 5 ones. And this is the notation for 111 whole star. So we need to add both of them together. So what is the first rule? For a plus b, we need to use this notation. So this upper part is considered as a and bottom part is considered as b. So here a is 111 whole star and b is all 5 ones. So we got this. So now we need to apply whole star on this complete output. So on this complete result, if you apply that whole star, you will get the result like this.